Hello, welcome to my tutorial on EF Core. Hopefully this will be the first video in a series of videos on using EF Core and other cool C# and programming topics. In this video, we're just going to create a database. We're going to create a couple tables and we're going to link those tables together, see the different relationships that we can do between tables, and get something working right away. I found, for me, when I was learning EF Core, some of the resources went a little bit too in depth, and it took a little while to get to a point where, oh, this is something you can use. But once you know how to make tables and link tables together, you can really do lots of stuff and practically use EF Core in your apps. So we're just going to make a very, very simple console app to explain how to do this. And then maybe in the next video, we'll do a Blazor CRUD app type thing, which will further build on the principles and illustrate what we have built here so far. So in this tutorial, I'm not going to use Visual Studio. I'm actually going to use Visual Studio Code. Unlike most tutorials, just change it up. I find when I'm learning something, sometimes doing it in VS Code and the command line helps me get my hands dirty a little bit more, and it feels maybe like I'm learning things a little bit better. We're also, instead of using MySQL, a SQL Server, a local database on MS SQL Server, we're going to use SQLite. And I like using SQLite when first learning because it saves the database as a normal, ordinary file, which is something we are used to if we're new to databases. We're used to just working with a normal file, saving data to a file when we're doing our word processing or Excel or whatever normal tasks we do on the computer. Now I'm also so before I get to that, we're going to use this tool to download to look at our database, SQLite browser. It's free. Go to SQLitebrowser.org. SQLitebrowser.org, and we're going to download that and use that. Instead of there's some really great database viewers, extensions for VS Code, and of course on Visual Studio has amazing database viewer, but we're going to use this neat SQLite data browser. I'm also using .NET 6. I'm using the OmniSharp extension in VS Code. If you've never written C# in VS Code, this thing is really neat. It's very easy in Visual Studio Code to write C#. But with the OmniSharp, you can also use Vim and other text editors that are not always used to write C#. So to follow along, really all you need is this cool C# extension. Okay. Now, and lastly, I am using the Windows terminal as my command line terminal. You can just use normal PowerShell. So I am going to skip just installing these basic programs, but everything else is going to be hand-holding. Okay, so let's start our console app and make a database, connect to the database, make some tables, connect them together, understand how all that works, and then we're done. So I'm just going into where I put my projects, and I'm creating a new console app, .NET New Console O EF Core Tutorial 1. Okay. Now the O is just what folder I want to put the project in. And now it is creating a new console app for me. So I'm just going to go in there. I'm doing code period to open it in VS Code, which I already had open. Okay. Wow, really groundbreaking so far. Now, I mentioned we're using .NET 6, so we can see what .NET runtimes are installed. I've got the latest few versions of .NET 6, and just by typing .NET list runtimes, just to make sure we're all on the same page, Okay. Now, we're going to install various NuGet packages as we go through that we need, although we're going to try to keep it to a minimum. So we're going to use SQLite, or do you say SQLite? Because wouldn't it be two L's, SQLite? Anyway, we're using SQLite, so we're going to install the NuGet package for that. Since I'm not in Visual Studio, we just type it in. So you know it, you can always search for in Google too, of course, and just download it from nuget.org. NuGet, like new metal. Okay. So, and that will always show you the latest version. I'm also going to install Entity Framework Core proper. Or rather, the NuGet package to work with Entity Framework Core in our app. Okay, now it's important to know that we have the Entity Framework Core command line tool installed. So .NET tool install global .NET EF, and I already have that installed, but you might not have it installed, and you would need to have installed it then. This will let us do all sorts of neat .NET EF, add blah, migrations, add blah 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 stuff that we're going to do in a little bit. Okay. Now let's look at our console app. We have the new HIP .NET 6 where it just works magically, no namespaces or program class or anything like that. Kind of freaks me out. I'm just not hip enough to use that feature, so I'm just putting in boilerplate. I realize I could just turn off that new feature, but we're gonna make our program in main once we get to manipulating the database. But now first, let's start creating our database. So the first thing we're going to do is create a context object. So what we do is we create classes that are just normal POCO, as they say, C# classes, plain old command line CLR objects, which comes from the old POJO, plain old Java objects back in the day. So they're just normal, boring C# classes, and we can actually, because POCOs don't technically are allowed to use attributes, I believe, we make classes, we can add attributes to them to make different parts of our data model required, max length, what kind of type we use. We're not going to do that so much today. But by simply creating classes, EF Core will then translate that magically into a database, and we don't really have to write our own SQL. We can if we want to, if we need to tweak things, but it's a very easy way to stay inside working with just C# as much as possible in our app, taking the data always as C# objects and then saving it into a SQL database, and then having EF Core bring that data back from the database back into our C# objects. And it's important to reiterate, this is for EF Core. We're not doing Entity Framework 6, even though we're using .NET 6. It's very confusing. EF6 is a bit older. It can only work with relational databases. It's Windows only. EF Core is cross-platform, like new HIP .NET 6, as was .NET 5 and .NET Core 3. as well as EF Core can work with both relational databases, which we're doing today, where we have tables, rows, your SQL database normally, and also non-relational databases, which EF6 cannot do. So the Azure Cosmos DB or MongoDB, which has some interesting properties, and we don't think in terms of rows and tables. So we can do all that via EF Core, but not EF6. So we're going to first create a class for our context object. We have the entity classes, which are the schema for a database, and those non-instantiated classes, we don't have to instantiate them to create a model of our database. They exist as a model of our database, non-instantiated, and then we instantiate a context object for our database, and we manipulate that context object. And that context object, which comes from the class dbContext, represents a session with our database. So I am creating a class, public class shipContext, which inherits from dbContext. And for now, we're keeping this very simple. We are only creating a constructor, a parameterless constructor now. And we are also going to override one of the methods that is in our wonderful parent class of dbContext. We're going to override the onConfiguring method so we can pass options, specifically when we want to tell dbContext where the database we are connecting to is and what kind of database we want to connect to. So we're going to take in a dbContext options builder parameter. I'm just going to call this options. Okay. Nice. Now, so it doesn't yell at us, I'm just going to put in some using statements. Using systems, we are going to use the list type and generics. We're going to use the file system because we're using SQLite, so we're saving our database to an actual file. And we're using Entity Framework Core. And not EF6, but Entity Framework Core. Okay, great. Now, let's create some fields for a context object. We're going to create two tables in this tutorial. One is a table of ships. The other is a table of crew members, of people who serve on the ships. So you can think of these tables just as sheets in Excel or Google spreadsheets that we normally work with. And then the magic happens when we create a relationship between these tables. Just as in Excel, you can take data from another spreadsheet, pretty much. So dbSet is the type that we use to create a table. Or say, eventually this is going to become a table. So dbSet is important. And we're a table of the ship type, which we have not yet created, the ship class, and a table of the crew member class, and we're calling it ships and crew. So now, down here, we're also, or should I come back to do that? I'm also going to, before we make our entity classes, we're going to create a field where we're going to store the file path to our SQLite database file. So I'm using auto property syntax, and since this is public field, the getter I'm keeping public, but I don't really, even though we're not doing anything where this really matters, in this tutorial out of habit I just made the setter private because I don't want other classes changing where the database file is loaded. We're just going to load that up when we start the app. So in our constructor, we're going to set the file path to our database file. So db file equals path combine, environment current directory. Now this from system.io gets the current directory that we're running the application in. It's using the path to get that path, and then we're going to put in a file name, and it's going to combine that path with this file name. I'm just going to do my-db. Okay. Cool. Now, we put this in the constructor. We could have made this the default property. Here, so it just defaults to that. Why don't we do that for now? We might use the constructor for other things. But I'm trying to, we'll keep this as simple as possible. So no constructor, just the default value for DB file when our app starts up is going to be our current path with my DB. That's the file name. Now we pass the options to our DB context parent. Or I'm sorry, we're overriding a virtual method in DB context. In our ship context class, when we create it, our context object, we create it with the options that we inherited from DB context to use a SQLite database. So we just pass it a string that says the data source is this file, and we use SQLite as an property. I'm sorry, method. So what's interesting is you can do useSQLite, useSQL, a bunch of different databases, and then you can put the connection string if you do useSQL here. But you're not supposed to do that. That's very insecure. So normally you create a JSON file, or use one of the ones already created when you do ASP.NET Core app, like in an MVC web app, or Blazor hosted, or in Blazor server. And then in your configuring JSON files, you would put the connection string there and then import the connection string here. But we're not doing that. We just have our field, this property, rather, has our path to our file, and then we put it in here, and we're good to go. So now all we got to do is create our classes for ships, our ship class and crew member class. And the database table will be generated magically from what we code here. So I'm just doing ship class crew member. Now, everything needs a key to identify it. We can set what the key is, you just normally using naming conventions. So if we do public int ID or public int ID here, EF-Core knows, because we chose the name ID, that this is the primary key for ship. So every time we add a row of data, each ship we add will have its own index, and the way we're going to do it, set up, it's going to auto increment, which is the default value. So it'll go 1, 2, 3, 4, 5 for every ship. And each person will have their own ID, 1, 2, 3, 4, 5. And we could override that and do a different kind of, instead of incrementing numbering system. But that works perfectly. Now we could have also called this ship ID, and EF-Core would know that this is still the primary key because we called it ship ID. So we can do just ID, or we can do the class name plus ID. Now if we called it donut, it would have no clue that this integer is actually supposed to serve as the primary key. The key in this table of each thing entered is unique. Although by default your keys do not have to be unique, but we won't get into that. So one thing we can do is we can put data annotations, we can put some attributes over this that just says key, because we chose a crazy name like donut, and it will still work as the primary key. So to do that, we're just using the system component model data annotations namespace. And now we can label donut as our primary key if we wanted to. But I'm just going to do ID. Okay. Now public string name. Each ship is going to have a name. And each crew member is also going to have a name. So all we have is a column, which is our primary key. Key for ship, key for crew, unique for each crew member, unique for each ship. And we could put lots of other stuff, but for now we're just going to have each ship has a name, each crew member has a name. That's all the data we're going to store. Now let's have a relationship between these two tables, between these two classes. So this table will store who are the crew members on this serving on this ship. Maybe it's 1,000 people, maybe it's 5 people, maybe it's 1 person. So the main 3 kinds of relationships are one-to-one. So each piece of data is now the same as another piece of data on another table. One-to-many. So we have one ship and we have 1,000 crew members on that ship. Or many-to-many. So perhaps maybe some crew members serve on multiple ships, the same crew member, and ships have multiple crew members. So it's many-to-many. So for example, I might have a crew record and it has 3 ships that this person currently serves on, and one of the ships he serves on has a record of this person is one of 20 people that serve on the ship. And what's so cool about EF Core is instead of having to come up with a SQL to make these different relationships, it's defined both by how we use what's called a foreign key and our C# reference. So just by making a list of crew members here, the ship EF Core now knows that this ship is going to have a one-to-many relationship with crew members, that we're going to have a list of crew members that serve on the ship. Now, just this alone, before I get to that, another thing to think of, if we only had ships that only were crewed by one person in a one-to-one relationship, we would do crew member crew. So this property is just a single instance of the type crew member that we created here. One crew member or a list of crew members. And we'll play with, we could also down here do list and this is a many-to-many relationship. Now, what's interesting about a many-to-many relationship, and we're going to create this in the actual database and look at how these look in the database in a second. But if we did do a many-to-many relationship, in that case, there's usually another table created just to manage that relationship. So there would be a relationship table, a third table that would have, okay, the ship X has crew members Y, Z, Q, B, ship B has these crew members, and that crew member has these other relationships as well. So sometimes you can think of it if you have a product page and you have a bunch of tags. So here are the books that have these tags, and here are also all the tags in existence. So many-to-many relationship. Now, let's see what... Now, another important thing is the primary key in the database. Each crew member is going to be identified by their key here. And when this primary key is in a different table being used is now considered the foreign key because it's left its table and it's gone over to a new foreign land and is now considered a foreign key. And in SQLite, each crew member will have their key here will be represented as a foreign key. Or rather, the way it will do this is that each ship will have a foreign key for each ship. So it will have crew member 1, this is the ship they are serving on, and it will have that ship ID, that ship's primary key will be a foreign key in crew member. I know I said I would make this video to try to make this simple, but I'm making something very simple sound complicated that is actually very simple. So it's like the exact opposite of my stated intent. But what is amazing is if we mess up and put foreign keys in the wrong place, often EF Core will just make the foreign key for us correctly. Now let's see what happens. Let's experiment with and see what kind of database schema is created when we try different things. So I haven't created a foreign key property. So what I should probably do is public int ship ID. So we have the C# reference, and then we have a key for each ship, the crew member. So we know there's going to be a list of crew that we're accessing, and then each one of those crew members, it's going to remember, hey, let's I serve on ship A, I serve on ship B, I serve on ship C. If add migration initial. So we're going to now create a migrations, which is translating our C# code into a script, which gets turned into SQL code, which creates our database for us. And we can do that from the command line with just .NET EF add migrations. Then we give whatever name we want to it. So I'm just going to say migration 1 or M1. Okay, please hold. Build started. Whoops. I typed that wrong. Add goes after migrations. Okay, one last thing we have to do is we forgot the NuGet package. Entity Framework Core Design. This is critical for being able to do a migration. Okay, now we're ready to make. So we've installed the normal Entity Framework Core NuGet package. We installed the Entity Framework Core SQLite package. We've installed Microsoft's Entity Framework Core Design package, and we installed the .NET EF command line tool. Here are the packages: Core, SQLite. Okay, design. Okay, now what's neat is if we type .NET EF migration script, we can see the SQL generated from our last migration. Okay, so we can see that it's creating a table. Primary key ships where we put ID, name ID, now, and we also created ship ID, and it recognized ship ID as a foreign key. Let's take a look at what this database looks like. So opening DB browser for SQLite, open database, just like opening a normal file. Coding projects and okay, that was embarrassing because we forgot to actually create the database. So now let's create the database. .NET EF database update. So we're taking this migrations, this SQL code, now we're actually executing it and creating our database and our two tables. So we've used 3 .NET EF command line commands, .NET EF migrations add, .NET EF migration script, and .NET EF database update. Okay, it applied the migration. Notice in our migrations folder, we have all the amazing code. And these are things that we can override or we can use. This is the Fluent API, and we can change this if we want things to be a little bit different. All this was generated simply from making a migration. Now let's open our new database. Going into my coding projects. Okay. Now here's the schema. Primary key for the crew. ID, name, ship ID. Notice this icon, recognized as a foreign key. And for ship, we have ID, our primary key, and our name. So this list of crew members does not exist in the database. This is for our C# purposes. And this also helps EF Core understand what kind of relationship we want. So for our many-to-many relationship, it's really, one-to-many. This will be very essential when we're working with the data, but it doesn't get translated into SQL and actually show up in the database. Okay, now one thing I find interesting, but you don't have to do this, but if I delete our database and I delete our migrations folder, if sometimes you screw up and don't put the key in the right place, for example, if we make crew member ID here, it doesn't really make sense that we would need a foreign key for our crew members, because the ship, it's not efficient for the ship to store an integer or a lot of integers, each one representing which crew member is on our ship, it makes more sense for each crew member to have a record of what ship they serve on. So if I put this here, or let's say I don't specify any foreign keys, and I do the same thing, migrations add, a new migration, build. It should be smart enough to create a foreign key for me. Here, although no foreign key ship ID was specified, which is very naughty of us, it was still created foreign key ship ID. And if we open our database file, I did not create it yet, .NET EF database update. If we now open our database, this foreign key was created in the database for each crew member because EF Core was smart enough to know if we want a list of crew members, those crew members should each have a foreign key of ships, should each have this ship ID key as a foreign key to identify what ship they serve on. So public int ship ID was made automatically here. Now, if we did a many-to-many relationship, and what if we didn't even specify any foreign keys? Would it create some? And it will create the reference table for us. Now, we shouldn't just not create foreign keys when needed because we want to interact with everything relevant in our object. So by not creating it, even though it's still in the database, we're asking for problems. But I'm curious what this will do. This should create many-to-many relationship automatically for us. Migrations add come on, computer. Okay. Migration script. All right. So, one table created, another table created ships, and now a relationship table created automatically. I believe that started with EF Core 5, that it would automatically create a relationship table when doing many-to-many relationships. We truly live in an age of wonders and horrors. EF tutorial. God damn it, I keep forgetting to make the database. Okay. Open database. So incredibly, this entire magic relationship table was created automatically because we did a many-to-many relationship, which manages crews and ships both in this one table. Now, did it create any foreign keys? It did not, because EF-Core decided that was not needed since we have a foreign key in this relationship table, crew ID and ships ID. But there is no crew member foreign key in ships, and there's no ships ID foreign key in crew, which makes sense if we wanted to have this kind of relationship. But I hope that was not just crazed rambling, and instead helped illustrate one-to-one, which would be crew. Whoops. Which would be crew member crew, one-to-one. One-to-many, a list of crew members. Or many-to-many, a list of crew members on the ships, and the crew members have a list, have their own list of ships. Each ship has a list member of crew members that serve on it, and each crew member has a list of the ships that they serve on themselves. And that is managed in a relationship table that was automatically created by the amazing EF-Core. Wow, 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 wow. Okay, but we're going to stick with a one-to-many relationship. And we're going to go ahead and indeed create a foreign key here of ship ID, because we might want to use that later. And we'll have EF-Core for real one last time. Just rmdb, deleting the database, rm migrations folder. Okay, so we have the model, we have our entity classes as we want them. Two tables, primary key, foreign key. This goes to that. And a list, a C# reference, a list of crew members inside our ship class. Let's create our migrations for real. .NET EF migrations add. I don't know why I need to change the name each time since I'm deleting the whole migrations folder, but whatever. Oh, now. And we could also, as it's reminding us, instead of deleting things, we can do EF migrations remove. Typo. Okay. It's created two tables with a foreign key of the ship. So each crew member has a record of what ship they serve on, which will be useful. .NET if data. I'm now holding a cat, so doing this one-handed. .NET EF database update. Okay. Let's open our final database. All right, crew, ships, foreign key, this ID, saved here as a foreign key and crew. This is a C# reference, not in the actual SQLite database, but very important. All right, now let's add some data. Did I miss anything? I'm going to go ahead and turn on nullables so we don't get green squiggly lines here and in the other code that we write. Okay, muffin. Whoops. So just for this file, so in our program to create data, we just instantiate this ship context class, which is our context object, which represents our session with the database. So we do this in a using statement, which creates basically a try finally block, and it destroys the object when we're done with it. So we just are have good housekeeping, although we're not doing anything that tests the limits of our computer's performance. Let's just add some ships. So name, obviously, this is going to be Star Trek ships, if that was not already obvious. Add new ship, Enterprise 1701, Enterprise refit, new ship, name equals Enterprise A. We're going to skip B and C. Go to Enterprise D, my favorite, and skip E. Okay. Now, this looks like it should work, but there's one other important thing. We have to save changes. This gets the data all ready to go. We create our context object, which represents our session with the database. We create a new object, a new instantiation of this entity class ship. We set its name, really the one property that's not just a key, which is generated by ifcore. We don't need to worry about generating the keys using the default options. All we're doing is setting the one field that's not auto-generated, the other field, the other property, name, refit AD, and saving the changes. Then this disposes of our context object. We exit the program, and that's it. So let's run this program. .NET run. Typing .NET run. Oh, one thing. When you're using SQLite, because it's an actual file, you're supposed to open and then close the file. So if something else isn't opening it, you don't get yelled at. But we're not going to do that because this is just a demo. But if it was a real app, we would bother with that. So I'm just going to close the database viewer. I've run my program. It's an amazing program. We're now going to open the database and see what happened. Okay. So here's the database schema. Okay, now we can actually browse data. So we go to this other tab, Browse Data. We haven't created any crew members, but we have created ships. So here's the ships we created. Whoop! Tucka, tucka, tucka. One, Enterprise 1701, Enterprise Refit, A, D, right there. Wow. Okay. We actually put data in the database. Let's add some more data. We'll do it in a slightly different way. Let's add some crew members and add some ships. And then we'll say the crew members serve on these ships. So I'm actually going to delete what we put in our database here. So I'm just going to delete rows, delete the current record by highlighted everything. Okay. Now I'm going to close this database, save changes, SQLite, just like working with a normal file. Amazing. Okay. So now we're changing our code. We're just leaving, creating the context object. That stays. Everything else is new. So let's create our crew members first. So another way we can create things is we create a local variable of the objects we want to create, save some space in memory, and then we use the add range method and we add them as a range to our context object. And how that works is we're using the crew member type from down here. Crew member, we're going to do Kirk, Spock, McCoy, and then Picard, Riker, data. Okay, 6. Now, we're taking this context object, DB, we're doing add range. We're saying Kirk equals new crew member, name equals James T. Kirk, Spock equals new crew member, equals Mr. Spock, McCoy equals new crew member, name equals Dr. Leonard McCoy, Picard equals new crew member, name equals Jean-Luc Picard, Riker, whoops, lowercase because it's a local variable, member equals name William T. Riker, data equals new Mr. Data. Semicolon. Okay. So now we've created a bunch of objects and added them as a range all at once to our context object. Now let's create 2 ships. Ship int and int d. So we're going to add these ships all at once as well. So int equals new ship name crew equals, now we can add the whole crew as a range here. Since we're using this beautiful list we created in our entity class, so all we have to do is new Kirk, Spock, McCoy, now the Enterprise D, new ship, name equals Enterprise D, 1701D, crew equals new Picard Riker data. Now we're using, remember we define these as local variables up here. And since we're still all local, it works great. Now before we leave this using statement, we want to save our changes or nothing happens. So now let's run this. And remember, we don't have to use .NET EF migrations or database update. That's just for setting up the database, creating the database schema, and running our migration, using our migration code to now use that script to create the database schema in the actual database. So that's what .NET EF is for and other database operations. But we're just running our app, and our app does wonderful database manipulation on its own in a very simple way. Okay, now let's open up our database. I just used the keyboard shortcut. Okay. Browse data. Now look at this. We have a crew table here, and it's using the foreign key in this column, ship ID of what ship each crew member is serving on. Even though Dr. Leonard McCoy is technically in Encounter at Farpoint, the Encounter at Farpoint, the pilot episode of Next Gen, that doesn't really count. Ships. The original Enterprise has an ID of 5. Enterprise D has an ID of 6. Now, why 5 and 6 and not 1 and 2? Because we have it using the default settings, it's auto-incrementing the ID. So even after we delete rows, it'll keep counting. So if we deleted 5 and 6 and we added 10 more ships, it would start counting at 7, 8, 9, 10, 11, 12, etc. Okay, so now we have successfully created data of linking two tables together. They have a relationship. And now let's make our app get this data and be able to print out what crew members are in with what ships. So I'm going to close our database again and we're going to delete everything. And now when we open our context object, we're going to be querying data. So everything still happens inside this using statement because everything we're doing is with DB context. We're working on the context object. So we're going to create a link query to just very basically get our ship's data. Now, if we only wanted just the ships without the crew members, we could do, hey, context object, get your ships, the ships class from here, defined here, DB set ships, get ships, and put that to an array. And then an expression tree is created. And once we loop through my data, it'll run the expression and it will print out each ship. But this is very important. The relationship data is not included by default, because if you have lots of tables that are all interacting with each other, it's considered very inefficient to pull in all that data each time you want to go to the table. EF Core is like, I'm not going to get crew member data unless you specifically ask me, because it's inefficient to include that crew member data unless I know you really want to work with it. So in order to get the crew data, we have to explicitly tell it. And one way to do that is to just simply say include and this is just like a link query, include in the ship s goes to dot crew. So when you get those ships, look inside the list, and this is why this list is critical, this list property that we defined, and get each crew member in the list called crew. And give that all to me as an array. Now, when you use include or then include to get even more data from a relationship, this is called eager loading. We are loading related data at the initial query. So we're eager, we're getting as much data as possible because we're not waiting till a later time to get the data. That is called eager loading. There's two other main ones called explicit loading, saying at this explicit later time, bring in the related data. And there's also lazy loading, where we just wait until we hit a navigation property, and then we get the data at that point. But here we're getting at the very beginning using eager loading. There's also a lot of other loading types, methods that we're not going to talk about today. But those are the three big ones. So let's loop through this. We're going to load the data in one other way just to show off. But for now, we're going to print out the data we've gotten before we do that. Item name. Crew complement is so all we do is we're getting the name of each ship item in my data. So that is ships from dpset ships. We're printing out what the crew complement is. And I think we just want to not put this on their own line. And instead of being like, is this the last one? If it's not, put a comma at the end. I just use this pipe thing. So for each crew member in item.crew, write out the crew member name. And this way we're getting the data from that first table of ship. So it's going to loop through, hit this first one, then it's going to, because we use the magic of .include, it is going to print out each crew member, get the related data from this table that it is linked to, and it's going to print out each crew member for each ship in this loop here, and then do it again for the Enterprise D, and print out its crew. Okay. Now let's run the program. Okay. Enterprise 1701, Kirk, Spock, McCoy, Picard, Riker data 2. Great. Now before I turn off this video, I'm going to show you one other way to include the data. So we could load the data at a later time, not at the very beginning here on our initial query, which is the eager way. We might not want to be so eager. We could instead load it. This is just yet another easy way to load the related data. We could take this collection. we could say, hey, now that you have this item, check out its navigation property. Show us that collection of crew members. Why don't you go ahead and load it? Now, of course, in production apps, a lot of this is async. So everything here has a load async. And then we could wait it, await load, but we're just showing off the database. So who cares? Okay. Now this should produce the identical program. Okay, that's all I wanted to talk about today. Thank you so much for watching this video. Please let me know all the incredibly embarrassing, humiliating mistakes I made, the things I got completely wrong. Let me know in the comments if another human watches this, and have a great night. Thanks so much.